Hello, I am going to be talking about slope today. So, what is slope? Well, when we're talking about lines, um, this is the equation for slope, and this is a point slope formula for a line, and hopefully you've seen these before. But generally, what slope is, it describes the steepness of a line. So, say you're going skiing on a slope. Let's say this is your slope. You want to know how steep the mountain is. Well, you don't want to go on a really steep mountain, say like this type of slope. So slope just gives you a description of how steep this line is going to be. And we'll get into those examples in a sec, but this is the formula for slope. So it's the change in y over the change in x. So you take any point, x1, y1, and any other point, x2, y2, and you find the difference of those, and that'll describe the steepness of the line. And I'll show you how in a sec, but generally we say rise over run, meaning if we're plotting this line, if we were plotting points on this line, we're going to say, well, if the slope is 2, that's 2 over 1, like we're going to do right here. And so we'll rise 2 and over 1, rise 2 over 1. And that's different than, say, a slope of 1/2, where you'd rise 1 and over 2. Where if you're rising slower than you're running, that makes for a less steep slope. So let's take a look at these examples. Let me dot those out. Okay. So this is our slope with a slope of, this is 2 over 1, which is a slope of 2x, right? I just wrote 2 over 1 because it helps us 2 over 1x, because it helps us see exactly how we're supposed to rise over run. But you could write 2 if you get the idea. So I plotted some points along here. That's these. And let's see what happens here. So when we look at, say, let's look at these 2 points from 0, 0 to 1, 2. Well, we said our rise is 2 and our run is 1. So when you rise 2 and you run 1, then you'll get to the next point, 1, 2. And what happens when we rise 2 and run 1 again? Well, our x is 1, and we're going to run 1, that goes to 2, and then we're going to rise 2, and that goes to 4. So we get to the next point, and you just draw the line in between the points when you're plotting. So you use this. I just made a table, said these are the values of x, and you plug in for x, and you'll get y. So you can do another one here. So we'll rise, what did we say? Rise 2 from 4 to 6 and run 1 from 2 to 3, and we get 3, 6. And this describes your line. You just take a ruler, plot these points, take a ruler, and draw your line through them, and you get your line. So let's take a look at something. So this was y equals 2x, right? The slope of 2. So what if we have a slope of 1/2? What's that going to look like? Well, you can see that the lower the slope, or the closer the slope is to 0, the less steep it will be. So let's black this out for a sec and look at this. So in this case, we're going to do rise over run, but it's slightly different. We're running 2 this time, so we'll run 2 and go up 1, right? So we can see this. I'll pull the whole thing. Now you can see it? Okay. So this is what we're looking at. So we can start with -2, 1, right? So when x is -2, and we want, oh, I'm sorry. Let me pull, this is the right equation. All right, so here's our slope, 1/2. Rise of 1, run of 2. So we will rise 1, so here we're at -1, and we'll rise to 0, and we're at -2x, so we'll run to 0. And you can see we can plot intermediate points here. So this isn't quite rising and running, but it's just another point along in between this. So we can, again, rise 1 and run 2. And that's in contrast, again, to our steeper slope, where we rose 2 and ran 1. Okay, so what about negative slopes? Let's take a quick look at this. So what if we add a negative in in front of here. You can see I don't have the points plotted this time, but you can see how immediately the line reversed, right? That's positive, that's negative. So when we have a -1, we are rise over run, so we are, instead of rising 1 and running 2, we are descending, so a -1 and running 2. And so you can try this on your own, try plotting some points with the same slope, but it effectively just switches the direction of the line when you add a negative sign. And again, also adding that b, y equals mx plus b, right? That's our formula for a line, with m being the slope and b being the x-intercept. So what if we add 1? It shifts the line. See, here, y equals, let's see, plus 0, right? Actually, I have an even better example here. This, I will include the link for this in the comments, so play with this. But here we have y equals mx plus b, and you can play around with the slope. This is the slope you're adjusting, so that's negative slope. Now we're going to positive slope, positive slope. You can see this is a positive slope of 3.7. You can see it's quite steep. And as we get even further, we'll get pretty vertical. Oop, I don't know what I did there. Okay, let's set this back to something like a little less steep. But you can see for our x-intercept, or sorry, y-intercept, that here right now the y-intercept is when x is 0, y will be 1. But if we shift this, it shifts along the y-axis. Let's make a slightly less steep line. And you can see how increasing this or decreasing this, it's the placement of where it hits the y-axis. Sorry, I said x-axis, I meant y. So go ahead and play around with this. I know this is exclusive, this video is meant for slope, and I talked a little bit about y-intercepts, but play with the slope, and generally it means the steepness of the line.